Today we're talking about the angle addition postulate. Now, in this diagram, how many angles do you see? You're probably thinking two, but there's actually three. You have this blue angle here, this green one, and if we look at the whole thing, there's this red angle as well, which is made up of those two outside rays. Now, I'm going to add some points to this diagram just so we have a little more specific way of talking about each of these angles. We have point A, B, C, and we'll call this point D. Now, again, naming our angles, we've got the blue guy is going to be angle ABD, where that middle letter is the vertex. The green is angle DBC, and that red guy is angle ABC. Now let's just say, I'm just going to make up some numbers here. Let's say the blue angle has a measure of 20 degrees. So there's 20, and the green angle has a measure of 50 degrees. What would you expect is the measure of the red angle? 70 degrees, right? So because those two smaller angles completely fill up angle ABC, we can add their measures together to find the measure of the larger angle. So in this case, the blue one is, and we'll put the little m out in front to stand for the measure of angle ABD. So the measure of ABD we said was 20. The measure of DBC is 50. So that makes the measure of ABC 70. Now, you guys, this is all the angle addition postulate says, is that if you have two angles that share a common side and also have the same vertex, then you can add those two angles together to get a bigger angle. So that's all this is saying here. Again, we see that same language as before. We've got the measure of ABD, that was our blue angle, plus the measure of angle CBD, that was our green one, and those will add up to the total, which is the whole thing. Now, a special case of this is when the two angles combine and they actually make a straight line. So something like that would be like we'd have our blue angle here and our green angle here. And now if we ignore that side that they have in common and look on at those two outside sides, oh my gosh, that red angle is really a straight line. Now we know that an angle that's just a straight line always has a measure of 180 degrees. So in this special case, those two smaller angles actually add up to 180. All right, so let's see a couple of examples of this idea. In this problem, we have to find the measure of angle BAC. So that angle is right here in blue. Now let's look at what information was given to us. So first we're told that angle BAT has a measure of 150. So let's find angle BAT. We go from B to A to T. Well, that's actually the whole thing. So this entire angle has a measure of 150 degrees. I'll just write it off to the side. All right, and we're also told that the measure of angle CAT is 30 degrees. So that is right here. CAT is 30. Now for BAC, I'm going to just call that X for now because we have to find it. So we have X, 30, and 150. Well, from the diagram, we can see that the X angle and the 30 angle combine to make this larger red angle, so that means they add up to 150. So we have our little equation, X plus 30 equals 150. From here, we'll just get X by itself. Subtract 30 on both sides. 150 minus 30 is 120. And so that is our answer. All right, let's see another example. Here's an example of that linear pair where you have those two angles that together make a straight line. That means that those two angles have to add up to 180 degrees. All right, so we know one of them is 100, and we know the other one, DBC, well, that's this guy in green. That's what we're trying to find. So again, I'm just going to call it X. So we have 100 plus X, and we see they add up to a line. So they add up to 180 degrees. So again, we'll solve for X by subtracting 100 this time, which means that X equals 80 degrees. And so then the measure of angle DBC is also 100. I'm sorry, not 100, 80 degrees. All right, great. Last example. So in this one, we're using a vocab word bisect, which means to cut in half. So here it tells us that the ray WX bisects angle AWB. All right, so I'm going to just find WX here. That's this ray in the middle. And angle AWB is this large angle on the outside. All right, so bisect means to cut in half, which means that now we've got two smaller angles, and those two angles are equal. They're congruent. So now that we know that these two, the blue and green angles, have to be the same measure, let's look at the actual numbers in the problem. So it's telling us that the measure of angle AWX, well, AWX, that's the blue one. So that is 50 degrees. Now, because of that whole bisecting thing, if AWX is 50 degrees, then BWX also has to be 50 degrees because they're equal. And so then when it says find the measure of angle AWB, the whole thing, all we do then is do 50 plus 50, which is 100 degrees.